Okay, so today we're going to talk about the substitution method, and this is for systems of equations, you guys. This is for systems of equations, so this is something new that we're going to be working with here. So you got to remember what is a system of equations, and hopefully from an activity we've done in the past, you know what it is, or you might need a refresher. But what a systems of equations is where we're going to have two equations, okay, that when they're graphed, so if you imagine there are two, so let's just say like y equals x plus 3 and y equals negative x plus 2, okay? If you were to graph these two systems, one of them would look like this, okay? And the other one would look like something, no, not exactly like that, something like that. And what it means is when you graph the two systems, the system has one solution, or has a solution, and that is where it intersects. So you would find the point where they would intersect, and then that would be the solution to the systems of equations. Okay, so a system of equations is more than one equation. Usually it's two, you can have three actually. But you're looking for where do the two lines, or where do the two graphs of those, so for these they're lines, we're going to work with lines here. So where do the two lines intersect? So that's what we're looking for when we look at systems of equations. Okay, so now not every time we're going to want to graph, though. Graphing is not always going to be the easiest. So we have this idea of the substitution method. So here's example number 1. Okay, so what we're going to do here is every time we see, we have an x equals 3. So every time we see an x, we're going to replace it with a 3. But we're going to do that in the other equation. Okay, we're going to substitute 3 in for x. So I'm going to use the other equation, since that one doesn't have something by itself, and we're going to substitute 3 in for x. So I see there's a 2, and then I see there's an x. Oh, that's 2 times x, so that's 2 times 3. Okay, so then I'm just replacing every x with the 3, and then I'm going to have minus 3y. Now I didn't substitute anything in for the y because we just know x equals 3. That's what we know. So I'm only going to replace my x's there. And then we're going to have equals 18. Now you're just going to solve for y here. This is an equation that we've solved for. You just solve for y. So 2 times 3 is 6, and then you have minus 3y equals 18. Now you just got to get y by itself. So we're going to minus 6 on both sides, minus 6 on both sides. Okay, and you get negative 3y equals 12. And then you divide by negative 3. So this is everything we've been doing in the past right now. So nothing new here. Y equals negative 4. So you know when we put 3 in for x, you get y equals negative 4. Well, that's your solution here, because we know what x is and we know what y is. So for this, we write our answer as a coordinate, and our answer is 3 comma negative 4. Okay? So if we were to graph these two lines, we would find that they would intersect at the point 3 comma negative 4. Okay, so here's another one. This time I have x equals 4y, and then we also have negative 2x minus 3y equals 22. Well, you can see here, x is already by itself in this first equation, and we know it has to be 4y. So let's use in the second equation, I'm going to keep underlining x in blue. Every time we see an x, we're going to put in a 4y. So here we go. So we're going to have negative 2. Now it says times, but it says x, so we're going to times it by, what was x? Well, it's 4y. Okay, and then we're going to have a minus 3y, and then we're going to have equals 22, so that part stayed the same. Okay, I want you now to finish this one out, and when you're done, resume it. Okay, so now we're going to finish this here. So we're going to have negative 2 times 4y is a negative 8y, okay, and then we're going to have that minus 3y come down. Ooh, this one's going to be ugly. And that's going to be equal to 22. Okay, so we have it equal to 22. And then we're going to have negative 8y minus 3y. Well, those combine together to get us a negative 11y, which then equals 22. Now we just got to get y by itself, so let's just divide by a negative 11 on both sides. And we get y equals negative 2. So now that we found y, we got to go back and see, well, do we know what x is? Well, we know x equals 4y, so why don't we use this equation here, and let's say x equals, and this is 4, but we know y is negative 2, so now let's just replace the y with the negative 2. So we're going to put negative 2 in for y. So we have x equals 4 times negative 2, which x then equals negative 8. Well, now we know x is -8 and then y would be -2. That is our point of intersection. So that is our solution to this system. This is where those two lines would intersect, -8 comma -2. And one way you could check this is go back into both equations and put a -8 in for x, put a -2 in for y, and solve it, and it should work on both sides. Okay, this one I want you to try. If you get stuck, resume the video, but try and find the x and the y value, the solution to this system. Okay, so here now, you see I have substituted in. Every time I saw y, I substituted in x minus 11 this time because y was by itself. So I want to substitute in, so I had 6x plus 3 times the quantity of x minus 11 equals -6. Now try and finish this one if that helped you out. Okay, here I went ahead and did the next step. So this is what we've been doing all year, distribution. The 6x just comes straight down here. We need to distribute the 3 into both these. So 3 times x gets you 3x. 3 times a -11 gets you a -33. Now you just need to solve for x. Okay, I went ahead and finished it here. That's why I paused the video. But I went and combined my x's then together. 6x plus 3x gets you 9x. The -33 just comes straight down. And same with the -6. Then it's just solving. So that's what we're doing. So then you should solve through it. You can check my work. But you get x equals 3. Now, once you get x equals 3, you need to go figure out, well, y is though. So now you're going to use the equation that you had at the above where I just put the star and solve for y. So every time you see an x, you're going to put in a 3. So we're going to do y equals, that's what we want to find, y equals x, which is 3, put that in yellow here, minus 11. And then so y equals 3 minus 11, which is a -8. So now we got to remember, put our solution as a coordinate. So our answer is 3 comma -8. And this is where these two lines would intersect. That is the point of intersection. Okay, so here's another one here. I want you to try this one now. Okay, this one looks a little bit different, but y equals -5x plus 7. Remember, that can be used or the other one. So every time you see a variable, substitute it in and check your answer with my solution when you're done. Okay, so on this one was a little unique. Both the y's were already set by themselves. So you can just basically take the two and set them right next to each other. So that's why I have -5x plus 7 equals 11x minus 9. I just took one y and I put it in place of the other one. So they set the two equal to each other, which is nice on this one. But you should get x equals 1 after solving that. And then you go back and substitute. It doesn't matter which equation you use. You can use either or. I just picked the top one. Okay, but you should get the same thing. And your solution for your point of intersection should be 1 comma 2. Okay, one more now. Okay, here's this one. Now I want you to try this one. This one might be a little more challenging. Give this one a shot and then check your answer with the answer when you're done. All right, so I went ahead and solved this one here. You can see I replaced my x over here on the right-hand side, put a star above it. That's a bad star, but that's where it went in. And you should get, after solving that and distributing, you got to distribute here. You should get y equals 18. Then I went back ahead. I just substituted in the top one here, and you substitute, then you get x equals -32. So the solution, or the point of intersection for this system, is -32 comma 18. If you graph both of these, you should get that answer. Okay? If you have any questions, please don't hesitate. Reach out to me and let me know, because this is what we're going to be working on for a little bit, for a few days.